Okay, so can you give a brief intro? Anything you want to share about like your years of experience? How much LeetCode have you done? Stuff like that.
Yeah, so I have about like 6 or 7 years of experience, mostly at like fintech startups, but I was not a CS major, and yeah, I'm kind of new to the leak code thing, so trying to spin up on it basically.
Okay, cool. Yeah, I actually did. I was a CS major, but I did a boot camp as well, and my previous company was fintech as well. We did like mortgage stuff.
Oh,
So
nice.
okay, so the first question, I'll just write it up here. So you're given a string, let's say sample ABC DSA, and you're given a K. So basically, what I want you to tell me is, can we make this palindromic by removing up to K characters? And so in this case, it would be true because if you remove the E and the D, you would get A, B, C, C, A. Just kidding. I think I said that wrong. So you remove the B and the E, sorry. So you remove the B and the E, and then you would get this. So this is true. And then basically, you know, another simple examples like, let's say we have the same thing, I guess, and K is 1, then I don't think you can do it. So this would be false. So basically, I just want you to turn like a Boolean of like, can we make the string palindromic?
Okay, great. Okay, so I guess just to kind of make sure I have understood the question, so we have a string, and a palindrome is basically like it's the same forward and reverse, and we're trying to figure out like if it's possible to turn the string into a palindrome by removing at most K characters. And so, yeah, like in your example, it was, we can remove this. I guess I'll just like start by writing down some observations or things I noticed. So, so if we didn't have the K constraint, then we could find out if the string is a palindrome just by using like 2 pointers. So one at the beginning, like one going left to right, and the other one going right to left, and then check that they kind of match. Um, and then the success criterion is like if they meet in the middle. And so I'm trying to remember if there's like a technique that is related to that that I can use here.
Okay.
Um, um, and my sense is that I think that this doesn't work because if we follow that, then like first we look at the A at the front and the A at the end.
Mm-hmm.
But then we look at B and C, and since those don't match, it's not obvious like which one of those we should remove.
Mm-hmm.
Um, so another idea is to kind of start from the middle and like do kind of 2 pointers from the center outwards, where like I'm just going to check to see if that works. So in this case, we would say like D is in the middle, and we would look at C and E, and we kind of have the same problem of like, do we remove these or do we keep them?
Mm-hmm. Yeah, and like you're gonna run into a bunch of like, do I keep one or the other? And because K can be up to like the length of the string, like you'll have a lot of choices. This is gonna get out of hand very quickly.
Okay. Okay, so I should have like maybe avoid the like pointer approach. Is that accurate? Like,
Well, so for example, if at every place you like, let's say you did some recursion, right, and you recurse like one or the other, what would be the time complexity doing it that way?
oh, like 2 to the n or something, like you have a
Yeah.
choice at each character. Yeah. Which
So
gets
so we
bad.
basically want an approach that avoids being exponential.
Okay, great. Okay, maybe we'll take a second to like think about this and see if I can like notice anything about this that will be helpful.
Sure.
Um, so like I'm trying to think if I can like represent removal from the string as something else, or if I can kind of measure like an edit distance or something, but I don't feel like any of those are leading to anything fruitful.
Okay.
Okay, so I guess I'm remembering I did a practice problem that was kind of like matching parens or something, and I don't know if that would be relevant. Like if I could use a stack and say, like push. No, I don't know if that is useful. Like if I push these onto a stack, then I know that I need to be able to like match every character that I have on the stack on the way out.
Mm-hmm.
Um, but I think I still have that like exponential like choice thing of deciding whether to include a single character or not.
Yeah, you also have to figure out, do I even want it on the stack? Like maybe the thing you're trying to match shouldn't even be on the stack.
Mm-hmm.
So I guess, is there anything you know that can take things from exponential to polynomial?
Oh, like dynamic programming,
Mm-hmm.
like to avoid kind of repeating work, basically.
Mm-hmm.
I see. Okay. Okay, so if I'm doing a dynamic programming approach, then I'm basically trying to find like, can I break this down into a sub problem that is easier to solve? Um, so for something like this, yeah, I guess I'll just like kind of brainstorm, but one idea would be I can go through each of these characters, decide like if I remove it, then now I have like a 4 string with like k equals 0. And that's like a much easier problem to solve to know if that is a palindrome or not. Um,
So can you explain that? Like you have your string. What do
yeah,
you mean by like a 4 string and remove a character?
sorry, like a len for so I guess what I'm thinking is if this was my problem,
Mm-hmm.
then one thing I could do is like in turn remove each character and then check if that's a palindrome.
Mm-hmm.
So it
Well,
would be
what if
like
k was like 500?
so then I would still remove one character. Oh, what would that turn into? Yeah, I could remove like one character and then say, okay, now you have a string of nk499. Does that kind of just break down into the same 2 to the n?
Yeah, so if you, like, let's say k is 500, you have to pick one to remove, right? you have to build the string. You have to pass the string as like an input, and then because you're removing a character, your string as an input would be there would be a lot of combinations. So yeah, I think that would still not be great. So is there any way we can make it better? Where like think about a better way to write it where you don't like rebuilding the string is expensive.
Yeah.
Also, you can't realistically pass every combination of strings into the function because there would just be too many. Because you would essentially be removing like every combination of characters and stuff, so it would be kind of the same exponential. Yeah.
I see. Would it be like would it be enough to just track the indexes of the characters that I want to remove, so I'm not rebuilding the string every time?
So how
But
would
it
that
would
look
be
like? Like, can you figure out if that's doable?
okay. Yeah. So this would need to know like yeah, I don't know, indexes to skip, which would be like a list of some kind. And then like the word itself, we kind of keep above, and then we say k equals something. It starts as the overall k, and then like the sub problem would be. I think I would still have to look at all the other like remaining indexes. So like I guess my base case. So my base case would be like if k equals 0, then just like check if the string is a palindrome.
Okay.
Um, and then the kind of like recurrence relationship. I basically want to go from like k equals n to like k equals n minus 1 on each step, or I guess like I or something. And yeah, I think basically I can just like add a new index to the indexes to skip.
So if you have, so just to understand if I'm getting it correctly, so you're going to have this indexes to skip list, and
Yeah.
at every recursion you'll just pick another one and add it to the list, and you'll pass it down to the next stuff. Is that correct? And then you'll decrement k until k is 0, and then you'll just like calculate how much that takes to make, or if it's a palindrome or not.
That is currently what I have, but I'm trying to figure out if that actually works or if that just is the same thing I described to you before.
Yeah.
In
So what
terms
do
of
you think?
I think it is still the same, and I'm trying to figure out if there are ways to kind of exit early, or if like we can know ahead of time before k gets to 0, whether it's like, yeah, I don't know if there's like a way to early exit so that we're not having to do all of this work.
So I think fundamentally, like the thing that makes DP work is there's not 2 to the n states, and things are cacheable. So if you have this indexes to skip array, like this can still be every combination of indexes, right? Because you're picking one, this, so this will still be 2 to the n.
I see.
So you need to rewrite it in a way where it's cacheable and the amount of states is small enough to where it's not 2 to the n. Where here, like if I just, once again, if k is like 1,000 and I pick a random index and I recurse, first of all, caching a 500 thing list or whatever is like not easy because you have to like turn it into something that's hashable, and a list isn't hashable. And secondly, that's still 2 to the n different combinations because you're essentially just picking one out of the whole list, and then you can have every single combination possible. So the recursion wouldn't help at all. It would just be basically a 2 to the n.
I see. Okay, so I have the same problem. Okay, so let me take a look at this example again and just trying to figure out like what the like tractable subproblem is. Okay, I guess my other idea, well, I don't know if this works, but like to kind of operate on a smaller string, but I feel like that's not super helpful because we still, like if k is the same value, like we often don't know if it's a palindrome until we've looked at the whole thing. So like it doesn't help to look for a palindrome in this section.
Yeah, so going back, you said like to normally check for a palindrome, right? You start out with like the left and the right and you compare letters and you move in.
Mm-hmm.
So what are the different possibilities you can have? And then how would you make that into a DP? Like when you compare letters, what are the different things that can happen?
I see. Okay. Oh, okay, that's helpful. Okay, so if we're doing like the two pointers thing, either like the left and right are the same, in which case we can kind of go to the smaller section. Yeah, like the or like s through 1 to n minus 1.
Mm-hmm.
Or they are different. And I think if they're different, then we don't know immediately like which one we can remove or which one we cannot remove. So I guess we could try like each of those cases. So we could say like skip L, sorry, like skip or sorry, this autocomplete is filling in. Or like skip both.
Okay.
And we can do that as long as like, yeah, we have like K opportunities. So we can yeah, K
Yeah.
tells us how many of these we can try.
Yeah. So what would that function look like? Like what
Okay.
inputs would you need and stuff?
Um, okay, I'll just remove some of this stuff.
Okay.
So let's know whatever it's called. So we have the word that we currently have. We have like our remaining K.
Mm-hmm.
And then I can say like L equals like 0, R equals len of word minus 1. And then I have these three situations. So like if L equals R, I guess I'm writing like almost code now, but
Mm-hmm.
we can like do this again. And then, oh, I need to keep track of, yeah, so I don't need to I don't need to build the whole word again. I can just keep like the left and the right indices.
Mm-hmm.
So in this case, we can do both. And then K stays the same because we haven't used up any of our Ks.
Mm-hmm.
And then so if we're not in that situation, oh, should I try and just write this out in real code? I'm looking at the clock.
Yeah, you can
Or,
write it in real code, I think. That's fine. And then we can talk about time complexity afterwards. That's fine.
okay. So I'll just write that, which might help.
Yeah, so just write an outer function that takes in a string and a k, and then you can use that. Yeah. Okay.
So I would want like this.
Mm-hmm.
And then otherwise, we kind of have a few different options. So we can like increment L. So I'll just write this out. So or we can decrement the right, or we can do both. Wait, am I allowed to do both?
Do you need to do both?
I don't think I need to do both. I think the recurrence will kind of take care of that and make sure that we get to both.
Mm-hmm.
Okay, so I'll need to like clean this up to make sure it's returning a sensible value. I think I also need to take care of my like base cases. So I want to say like if So if L and R have met in the middle, then I think that's like a successful case. And I think they can be off by 1 and it would still be fine.
Okay.
So I like, or I guess left is always right. So if I don't want to check if that is correct, but I think something like this.
All right.
And then if K like has dropped below 0, then so yeah, if K is below 0, then we've used up all of the potentials like removal, so that doesn't work. And so for this, I think I want to return like if either of these works, then we're happy. So I think this needs to be an OR.
Okay.
So we would start with like okay, so I'll just check this.
Sure.
Yeah, so for this one, I just want to make, I'm basically just trying to say like, are these two, they have either met or are like right next to each other. So I think that that is correct. I guess if they're next to each other, we still need to confirm that the two letters are the same. So I think in fact this is wrong. So I think I just want to say if that.
Okay.
Okay, should I try and test it?
Yeah.
And are we doing okay for time?
Yeah, so we have about 28 minutes left or something.
I spelled it.
Okay.
So if I had 1, okay, it worked on that case. I can test a few more if you would like, or do you have any thoughts or questions?
I would say just test anything you think is relevant and we can move on if you're happy with it.
Okay. And that one's not correct. Okay, I have a bug somewhere because it should be able to catch that this works.
Okay. I suspect the bug is in this clause, but I'll just double check. Sure. I think that print
Yeah.
should give you what you need. Have any ideas?
Is it? It seems like it's not evaluating the case that I want it to, which is like skipping over this C. So that would be indices like 0 to like 0, 3. I would or no, sorry, it shouldn't. It would do like 1, 3, which is fine.
Yeah, so it's recursing to
It'd
these
be-
two.
Yeah.
And in both of these, this is false, right? And this is true. Because k is 0 in both of these. So it's getting down to k is 0, and then it's just returning false.
Oh, I see. Oh, do I need to just flip this around?
Okay.
Okay, that fixed it, but I guess I could just do this and say if k is less than 0.
Mm-hmm.
Just double check that. Okay. Okay, so I think this is equivalent. So it's like, yeah, if we have actively used up all of our deletions.
Mm-hmm. Okay, good to move on, or do you want to test anything else?
Yeah, I think happy to move on.
Cool.
Thank you.
Okay. All right. So for the second problem, you are given input like this. So you're given a string, and it's like this. And you're given another string of ones and zeros. So be like that. Maybe let me write it a little bit better to make it cleaner. So let's say it's like this. So you don't have spaces in practice, but like I just want to have it like line up so it's easier to read. So basically, the first string tells you what parenthesis you have, and the second string, so 0, means this parenthesis is unlocked, and 1 means it's locked. So unlocked means you can change it to whatever you want, and locked means it has to stay the way it is. And basically what I want to figure out is, given this string and this like locked string, can I figure out if I can make valid parentheses, changing, like if I need to change anything I can, but basically taking the ones that are unlocked and modifying them. So in this case, you can. I think in the first case, it's actually already all like done, right?
Yeah.
So let's say it was like, I think I copied it again wrong. So let's say I had this. So this would still be doable. So this would be true. Because this first one, for example, is unlocked. So I could do something like change this to this. And then these last two are also unlocked. So I could do something like that. And then that would give me the right result. And then to give you one more example, let's say we have, a simple one. Say we just have like this. And this locked thing happens to be all locked. Then this would be false because like this is not valid and you can't change anything. So feel free to ask anything you need to.
Okay, that is helpful. So yeah, so I guess to restate the problem, like the zeros and ones basically tell me if I can change the parentheses, and is just changing mean just like swapping them around, or could you also like delete one if you wanted to?
No, so the ones that are unlocked, you can either leave it as is or swap it. So it's like, but it's not like swap with another one. It's change its own value.
Or yeah, like flip it. So you can switch it from like an open to a close or a close to an open.
Or leave it as is, yes.
Or leave it as it is. Okay, great. So these examples make sense. So yeah, so I guess I'll start with like the thing that immediately comes to mind is like if we didn't have any of this locked logic, then we could like figure out if we have a valid set of parens just by like counting the number of open and closed. So we could say like, I'll just try and describe this. So like an open paren means like +1 to the count, and then a close means like -1.
Mhm.
And then like for this to be valid, like the final one should be 0. So we've balanced it. And then I think also we can never go below 0.
Yeah, that seems
Which
correct.
would, which would represent like having a closed before an open.
Yep.
So I think this describes the like simpler problem
Mhm.
of no locked and unlocked. So I'm trying to think about like how does the locking logic affect this, or can we still use this?
Sure.
And yeah, like one kind of like observation that comes to mind is like a lock basically enables us to choose between these two. So yeah, we like if we have a 0, then we can basically pick either an open or a close to go in this location.
Yes.
Um, and so like yeah, one thing I'm thinking is like we could keep account of like the like basically instead of just one count here, keep track of like the lowest possible number and the highest possible number. So like we have a low and a high, and then like every time we encounter an unlocked paren, we like decrement low and like increment high to represent like all of like the kind of range of possibilities that we are still allowed to entertain.
Mhm.
And then I think I'm just trying to figure out if that is enough or if there's something else that we also need to do.
So you'd have this low and high with the opens that you would kind of like have this range. And
Mhm.
then for the what happens when you hit an open or a closed that is locked?
Then we kind of fall back to this logic. So an open like adds 1 to both of these low and high, basically, and a close like subtracts 1.
I see. So low and high is the count of opens.
Hmm.
Like what is yeah? I guess what's the count of? Or is it the count of both open and closed?
So it's supposed to be like it's almost like low is if we choose like close for all unlocked parens, and high is if we choose open for all unlocked parens.
I see. So it's like the
So
count. So this is like the difference. Like it's the count
yeah,
of like open minus closed.
essentially, yeah, it's kind of trying to track like so this is supposed to represent like the kind of state space or the range of possibilities that are open to us because of the unlocked parens.
Uh
And
huh.
then like the idea that comes to mind is like uh there are some choices that we can't make, right? So like if we have this, um we could not make this a closed because that would be invalid immediately. So I think we still need for like low can never go below 0.
Yeah, because
Um,
so that definitely is needed if you do it this way. I
yeah.
don't know if this will work for everything. I've never seen anyone try this, so I guess we'll see.
Really? Oh.
Yeah.
Uh,
But at the same time, I'm not seeing a problem right now. So I guess we'll see what happens.
oh, interesting. We have like 15 minutes. I like
15 minutes,
the
yes.
other like idea that comes to mind is like using a stack where you push like yeah. So I've seen a similar problem where you have different types of parentheses, and then you want to use a stack because you want to keep track of making sure the opens and close match. But I feel like
Okay.
in this problem, a counter like is effectively the same
Well, I guess we
thing.
can try it your way, and then we can swap if you see a problem, or you can you can test appropriately and things. So you're basically
Yeah.
saying, so let's just walk through the rest of it. So you have this like
Mhm.
low and high, right? And then when you have this when you have an unlocked, you basically increment high, decrement low, but you
Mhm.
can't go below 0. And then when you have an actual value, then you like increment or decrement appropriately.
Yeah.
And then what do you check for in the end?
You basically check that like 0 is within the bounds. So like 0 is between low and high. So like, yeah, something like this.
Okay.
Because then that shows that like there is a valid, like it means that the parentheses balance if we choose the right like locks and unlocks along the way.
Okay. So coming back to this example, maybe we could
Mhm.
walk through some of these.
Yeah.
What would happen?
Okay, great.
So this
So
would be actually, I think this started off like this.
great. So okay, so yeah, so like the first one is like, so in theory we could choose whether it is left or right, or sorry, it's open or closed. But I think because low can never go below 0, like this one would have to be like a +1. So we would essentially like, let me just think about this.
Okay.
I think
Yeah, actually, that is a good point. Like, will this break anything ever with these cases? Because your low and your high are 0. Low can't be decremented. So then what do? Do you increment it?
right,
Or yeah,
like
what would happen?
I see. Um, yeah, so like if it was possible to remove this, then we could say low, like we could just leave low as it is.
Mm-hmm.
But I think in this case we would have to like add one
Okay.
low, and then I need to figure out what the logic is to decide like when is it that low has to be incremented versus
Yeah,
um,
maybe that might be buggy where it's like your low, like if your low is 0 and you have a parenthesis, you can't make it negative, but maybe it could have been 1 and now you can make it 0 or something, something like that. Like, can you account for that, I guess?
I guess there could be a line in there that is like if low is at least 0, like is above like
Well, low
and
is like as low as possible, right? So low is always going to be 0, actually, thinking about it. Like low can never drop below 0, but well, I guess maybe it can be
uh,
1 technically. Um,
I think it could be, well, no, like if you had a string like this,
oh, that's right.
like
It would just keep
this,
incrementing.
it would
Yeah,
keep incrementing here, so
I
it can
see.
get pretty high. So I think it's something about like if like I have an unlocked and like decrementing low would cause it to drop below
Mm-hmm.
0,
Mm-hmm.
and I can't do that. I have to like choose the +1 option.
But if it was basically, it's like if you can have 1, then you can drop. But if you can't have 1, then you have to go up, right? So you have to find some way to differentiate like that case, I think, if that makes sense.
I didn't fully understand that. So
Yeah. So if low is 1,
yeah,
then you can
okay,
drop.
yeah,
But if low is 0,
hmm
you can't drop and you have to go up.
yeah,
But you also have to know that it's not possible for it to be 1, because if it could be 1, then you could drop to 0, right? So basically what I was saying is like if low is 1, you can drop here, right, to 0.
hmm
If low is 0, you have to go up. You can't just do nothing.
yeah,
But you have to also know that low equals this doesn't exist. Because if this was the case, then it could be 0. Does that make sense? Because this could drop to 0. So like you have to be able to differentiate, which I'm not sure. Maybe it works, but
hmm
that's kind of like the tricky thing I'm thinking of.
Oh, interesting. Yeah. I mean, my sense is that this would resolve itself because, like, if we say low is 0,
Mm-hmm.
then we're just saying like the minimum possible value for low is
Mm-hmm.
0, and so like we Oh, I see. It's like, so what that basically means is that one of the unlocked parens that we've seen up until now has to be like clamped or like has to be an open, but we don't know. We can't necessarily say which one.
It's basically, yeah,
Yeah.
like if low is 0, you have to know that it's 0 and it can't be 1. Like it has to be like low is 0 and 1 isn't possible. Then you know it goes up. If 1 is possible, then it can stay 0. Does that make sense?
Right. Yeah, I think like yeah, that framing is a little confusing to me because low of 0 just means like 0 is the
Mhm.
minimum possible value for low. So um okay, maybe I might try like a really simple case and just see if it works on
Sure.
that. So like if we had this, um, then so okay, so we start with low and high as 0.
Mhm.
Okay, so we process this one is unlocked and it cannot be like low is already 0, so this has to be a +1.
Mhm.
This has to be a +1. Um, and then this one is locked, but it's a -1, so it takes us to like -1. So we're good. Like this can just be that.
Yeah.
Um, so if we complicate it a little bit more,
Mhm.
um, like what would be the example? Like this. Okay, I wonder if this will illustrate it.
Okay.
Yeah. Okay. So yeah. So after the first one, low has to be +1 because of the reason we said.
Mhm.
Here we could drop it, so we would say this could go back to 0.
Mhm.
Um, +1 because this is a hmm. What is I think high becomes a +2 here because we
Yeah.
could choose to flip this the other way.
Yeah.
Okay. And then for each of these two, they're locked, so we just have to like subtract -1, -1 for each of these. And yeah, we get like high equals 0 at the end. And 0 is still within the bounds, so I feel like that would work.
Okay. Yeah, I guess for these cases, so this low is technically not being tracked. Like, it can't be negative. So, like in this case, it would be, I guess, like you can't remove
uh,
parentheses, but like I'm still not super sure
yeah.
it'll work, but I guess we can try it. Like
Okay.
I feel
Yeah.
like some sort of it might work, but there might be edge cases, and I'm not entirely sure. But we can try it because we only have like 6 minutes left. So let's just go with this.
Okay. Yeah. Sorry. Maybe I should have like explored a different approach instead of this. But okay. Well, I'll try it and see.
Okay.
Um, so we'll say like it is valid. Um, say parens. Um, um, did you call this? So the locked is 0 or 1.
Hmm.
So, um, I don't want to use. Okay, and then I have the kind of the cases described. So like
Hmm.
if is locked, then I guess I'll just write it out. So if p equals open, then we do like low plus equals 1.
Hmm.
And then I guess we don't need to sanitize inputs, so we can just assume that the inputs will be valid.
Oh yeah.
Okay, so I need to figure out this king. I just want to write out what the like.
Okay.
So yeah, I just want to check that this will work. So I also want to confirm that low never drops below 0. So I'll just test this.
So
This is not doing any of the locked logic.
okay.
Yeah. So I just want to check that this is okay. So that is working, and then now this one, I think, is the one that will break. So now I want to just confirm that this will work. So, or 1 second.
Mhm.
All of this should go below the else.
I see. Yeah.
Sorry. Yeah. I was trying to write the simpler logic first. Wait, sorry. Yeah, so if it's unlocked, then we have the ability to change, right?
Mm-hmm.
Okay, so I think this was the more complicated logic. So I think we're saying that like if I'll try and write the logic I had here.
So if it's unlocked, does the parenthesis you have matter?
Oh, good point. Okay, so yeah, if it's unlocked, then I want to do like low gets decremented and high gets, so we could choose either of them, unless if this would cause low to drop below 0, then what do I want to say? If it's less, I think yes, I think it's like if it's less than or equal to 1, then we have to increment.
Okay.
Something like that. Okay, so that did not work on this simple case. I just want to see what happens if I don't enforce any of this stuff.
Yeah, sure.
And
So if you don't enforce it, it should always tell you true, even and then we might get false positives, right? But it should always say true.
right.
So why is it saying it's not? Oh,
Oh, I haven't. Sorry, maybe
oh, you have this.
just
This
doing
is
this
why
is.
it's turning false, right?
Oh,
Because here you're not enforcing, and this can go negative.
I think I might also not be parsing this string correctly because I think it's treating a 0 as a string 0. Does that get?
Oh, I see.
I don't know if Python does that correctly.
Yeah, I haven't done zip of strings before, so I don't know what that does.
Yeah, I'm worried that it's maybe treating.
You can print it.
Oh yeah.
I would imagine it makes a tuple, and then it is what you expect. It makes a character tuple. Yeah, so that is correct, I think, right?
Let me just check. All right, so I think it's evaluating the 0 to be true because
True.
it's a string.
Oh, I see. I see.
Uh,
So you need to turn it into an int and then check. That's one way to do it, I guess.
yeah, sure. Okay, I'll just do it here.
Oh, that works too. Okay.
Oh, sorry.
Okay.
Okay. Okay, so at least we're now checking this correctly, and then oh, I guess yeah, it's a lot of branching happening, but I want to kind of enforce the thing of like if this would cause low to drop below 0. Okay, so that is now processing this one correctly.
Okay.
Okay, it's processing that one correctly. And then, yeah, I'm sure there's an edge case that we do not handle correctly.
Yeah, I'm curious myself. I think the case is like the yeah, I mean, I think doing the greedy like never just going down and checking if it's in the range, like I think it can be in the range, but it doesn't cover every value is the problem, I think. Right? So I might have like -10 to 10, but like it doesn't cover every single one of these. Like there might be gaps and stuff. And you have to know it's like zeros covered. But yeah, I think
Okay. Yeah, I might try and run this on some more like challenging examples and see if I can break it.
I think this is actually failing on the here I can give you one.
Oh,
I think it's
yeah.
actually failing on like the base case I gave you. So if you try like these two, it fails on this one. Unless you change some stuff.
Okay, so this one we expect it. Yeah, so you should be able to do that and swap this.
Yeah.
I see. So it didn't pick that up.
Mm-hmm.
Interesting. Okay.
Okay, so we're at time, so let's just stop.
Yeah.
So I guess like, what are the things you think you did well, and what are the things you think you need to improve in?
Yeah, I feel like it just took me a while to like get to the heart of the question, like especially on the first one. I felt like I kind of was spinning in circles a little.
Mm-hmm.
And then like once you mentioned like dynamic programming, that was helpful. And then yeah, like figuring out what the appropriate sub problem is. Like I feel like once you asked me to like write out the possibilities, like that was very helpful.
Mm-hmm.
But I feel like I should have got there sooner or like yeah, quicker.
Mm-hmm.
And then the second problem, yeah, I guess I maybe just went down the wrong rabbit hole and should have like stepped back earlier instead of continuing with this like ranged approach.
Yeah.
And like focus on correctness.
Yeah, so I think for the first one, you like I think the big red flag for the first one is I hinted you to do DP, and the way you were making the state wouldn't work for DP. So I think, in my opinion, that means like you don't understand like the fundamental DP of like super, in depth of like how DP works, how time complexity for DP works, things like that. Because you kind of had like three solutions that were still two to the n. And I had to kind of point out to you, I was like, if you have a array as an input, first of all, you need to be able to cache it because DP needs to like you need to memorize. So you need to take an array, let's say it was like 1,000 items. You need to like turn that into tuple or whatever, a string or something, which is like expensive. And
Mhm.
also because you're taking random numbers and putting them in, that would still be 2 to the n. So I had to kind of point out to you a decent amount of hints, not like I feel like if I asked you, hey, how do you turn exponential into polynomial, and you said dp and you like got it from there, then that would have been
Mhm.
fine. But because I
Okay.
like hinted you a lot for you to get where you needed to be, I think for like senior, or like I mean probably like mid to senior, is like I think you're expected to get more of that on your own, um,
Mhm.
without so many hints. And then also, small thing, I would probably accept both. So here you have LRK. You can actually do this with just LR, because basically, if you have the case of they're not equal, you just do 1 plus and then you modify L and R. So then K doesn't even need to be here. And then that would be like a improvement. Maybe for LR, like K is always the same and then it's n squared. I have to think about it. But yeah, basically one of these states is like not needed. So like the optimal would have been just do it this way. And then this would just be like when you increment it would just be like 1 plus or 1 plus, because you're instead of counting
Mhm.
how many letters you have, you just count up like how many letters do I need to remove, and then you just return the min of those. And if you can take your whole word and get it palindromic with removing k or less, then the answer would be yes. So basically, your problem is just like what's the min letters to remove to make it palindromic, and then you just check is that k or less. Does that make sense?
I see. Okay. Yeah. Interesting.
Yeah, and then
Uh,
the other kind
yeah.
of like red flag ish here, you had the wrong, like in your base cases. First of all, you had the wrong one to start out, so you had like this, right?
Mhm.
And I pointed that out. Secondly, this is still wrong, because if this is the case, that means you remove too many letters. So if you remove too many letters and the rest of it's a palindrome, it should still be false. So this should be swapped. So this should be like up here.
I see.
Um, and so I think you need to recognize that was another, basically, like I was like, so you have base cases, but they're in the wrong order, because here you'd return true and it shouldn't be for this kind of thing. So I think definitely like your edge case handling can be improved. You need to like really figure out, okay, how does DP work fundamentally? How does big O of DP work fundamentally? How do I take a problem and make it into DP? How do I set up my base cases in a correct way? And this was like a harder DP problem, so but I think for higher level, like that's pretty reasonable.
Mhm.
So and for what it's worth, like if you look at it, the code's like 6 lines, right? So it's like not something crazy. Um, you just have to figure out like what you actually need to do. So I'd say that was like that for the first one. Yeah, I definitely think the second one, you like, I was just not very sure. Like I was like, this could be some greedy thing, but it's really not obvious that it would work. Like maybe, maybe not. And I was like, okay, so you have some range of like high low, but like what if a bunch of the numbers in between here aren't covered? Like what if 0 is in the range, but you can actually never get 0? Like I could totally see that being and it's very hard to prove. So I think
Mm.
if you go for like I would say this is like a greedy type of thing. If you go for like a greedy solution and it's very hard to prove, I would probably tend to stay away from it for something that's a lot easier to prove. Because here, like, I just had no confidence that it would work. I was like, maybe, maybe not. And like, I
Mhm.
don't think you did enough to convince me that it would work as well.
Mhm.
So I think for greedy, you'd have to be like, it would work, and here's why, and here's like step by step of like how I got there. Where this is a common thing I think people do in LeetCode, where they're like, so I think I could take this like greedy thing, and then I'm just gonna run it and see what happens. And like in an interview, you can't really run into like imagine you find some edge case and you're like, oh, this actually doesn't work. Like
Right.
and you go and you do this whole thing and you're like, oh crap, I got to delete it all. That's like an instant fail. So I would
Mhm.
try to go for solutions that are more verifiable. And then I think you mentioned like stack. Like stack would still be like O of n. It would just be a stack, and it's a lot more verifiable. And like I know that it works. That's why I said like I don't think I've ever seen anyone do this, and I was like I don't know if it would work. Um, and yeah, I would generally try to avoid those unless it's very obvious to you that this is like clearly works. So I think if you think it's like unless you thought it was like 90% chance or whatever or more to work,
Mhm.
I would just go with something that's a little bit more provable. Does that make sense?
Yeah. What was the like expected solution for this? Like to use like two
Yeah,
stack.
yeah. So there's two
Uh,
solutions that are expected. One is very tricky and one is more straightforward. The very tricky one is based off of this, the count of closed parentheses can never be less than 0, or the overall count can never be less than 0. And if you actually go both ways, like if there was no locked in a real valid parentheses, you can actually go both ways, and then you can just check that the count is never less than 0. And that means that you never have more open than closed overall. So if you think about it, there's no way to write it. Like if you have too many opens and not enough closed, if you go the other way, you're gonna hit a negative. So the tricky solution is go both ways, and then basically the key thing to figure out is I have two types of parentheses. I have a unlocked, and I have an open. And this is kind of a little bit simpler. It's like, okay, if I have a closed parenthesis, which one should I use?
Right. Okay. So you should try and match the open ones, right?
Yeah, you should try to match the open ones, and then you basically just make sure that you have I forgot exactly how it works both ways. I'd have to look at my code. You have to make sure that the unlocked at the end is just even. And you do that in both ways. I think that one's a little bit counterintuitive. The simpler one is a stack. So you have a stack of open, and you have a stack of unlocked. Okay? And you only go left to right. And whenever you hit a closed, same kind of thing. You just pop off open. And if you don't have an open, you pop off unlocked.
I see.
And this makes sense because like you're like, well, one is modifiable and one has to be open. So if I have to pick one, I'll just use open because it's like I can't change it. So then at the very end, so if you ever hit a negative, then you know like you don't have enough parentheses, because that is basically your high, right? Open plus unlocked is your high, essentially what you did.
Right.
So if you hit a negative there, then your high is like negative, and then you can't do it. So at the very end, you have a stack of open and you have a stack of unlocked. Then basically what you need is for every open parenthesis, you need to match it with a closed. So the way that works is you can just go, like, then you'd have to figure out, okay, for all my open parentheses, I have to match it with an unlocked parenthesis. And how would I do that? So if I have an open parenthesis somewhere, what closed do I want to match it with? Well, the one I want to match it with is like, I basically want to match the ones at the right with the ones at the right. Because like imagine I have some stuff here and I have an open here. I want to match the ones at the very end with the closed ones at the very end, because these are the hardest ones to match, right? Does that make sense? So essentially you just pop off the open and you pop off the unlocked, and you make sure that like for every one you pop off the open, there's an unlocked one that's past it, because then that's a match.
I see. Okay.
And then basically you run out of open. And then the last part's pretty simple. You just have something left in unlocked. And as long as that is divisible by 2, then you can just match unlocked with unlocked. So that's like the full stack solution. I think the going only left to right is a little bit more intuitive. So that's the one I would expect. And obviously, once again, this is like a pretty hard problem. But, I can give you like some hints here and there and like whatever. So the only things you really need to solve this problem is those same concepts from before, where it's like, if I ever hit a negative, then I have an unmatched closed and I know it's invalid. And then the other like concept you need to figure out is, okay, if I have a closed, should I match it with an open or unlocked? I think that one is also pretty straightforward. It's like I want to match it with the one that can't mutate. And then finally, the last one is when I have an open parenthesis, how do I match that with unlocked? Like, what's the way to do that? So there's like a few like things you have to recognize, but it's just like normal problem solving. It's not anything crazy.
Right. Okay. And then, I think once you get those insights, then the code is like pretty straightforward.
Yeah. The code is like 20 lines again or whatever. Yeah. So I think, the main takeaway is like, don't go for solutions that you aren't sure, because it's an auto fail if like your assumption was wrong. And then like you test an edge case and you're like, oh crap. Or I give you one and you're like, oh yeah, this would actually just straight fail for this.
Yeah. Makes sense.
And then also just review your fundamental, like how things work. And I don't know, like what types of, I think you said you started doing some hards. So I would say these problems are definitely difficult to do if you haven't seen them, but they're definitely not like unreasonable to ask. So like I think if you've done enough, you should definitely be able to get these problems and like figure it out, because you have kind of like the fundamental stuff, and there's like 1 or 2 things you need to add on to like get it right.
Mhm.
So it's all building blocks of the lower stuff, but you just need to figure out like a few more intuition things. And so yeah, I think DP is a really common thing of like, how do I write states in an efficient way to minimize my time complexity? And then for the other one, it's also like, there you get some stack problems or something. You're like, how exactly do I do this? One stack, two stacks, whatever. I think these are both good though to test actual problem solving, because they're like very rare. You don't really run into something exactly like this ever, and you have
Mhm.
like enough to learn them. So
Yeah.
so I think these are like pretty good to ask and stuff. So yeah, and I think when I asked this before, I don't think I asked the first one before. I think when I asked the second one before, someone did solve it, or they solved it with like minimal hints. But I think definitely from what you did, like just if you do DP and you try to store a list, that's already like you have a genuine misunderstanding of like how DP works. And then I think the difficulty of the problem, it doesn't matter. It's like your fundamental understanding of how DP works is wrong, so you need to like correct that and like redo it and things like that. Does that make sense?
Yeah, I mean, for the DP thing, like I kind of, yeah, I was like aware that you cannot like memorize a list and stuff, but was trying to
Uh-huh.
figure out like what is the tractable subproblem, and it just like wasn't quite coming to me, which was frustrating.
Yeah, for sure.
Yeah, until we kind of like got down to like once we got to here, then it became clear.
So I think generally what you can do for DP is you can be like, okay, I have infinite space.
Mhm.
Like, what are some things that are pretty reasonable to keep track of? And it's like, well, to keep track of a palindrome, you need the left and the right. You need the left and the right index. You can't really do it from the middle, but like think about like if I have infinite space, let me just keep track of as much as possible, get something. And then
Mhm.
once I get that, then it's like, okay, what's redundant? What can I get rid of? How can I simplify things like that? And you should try to come up with a solution that's like basically, yeah, I have something exponential. I need to bring it down to polynomial, basically always DP. Oh yeah, the other thing for DP, the other thing that was like a red flag was you never cached anything, so this would still be exponential.
Oh, right, yeah.
Yeah.
Oh yeah, sure. Uh, um,
And it's like pretty easy to do, but like for your level, I would expect me not to tell you to do that. Like if you're like, intern or new grad, it's like okay. But
mhm.
like if you have enough of these things that are wrong and like fundamental misunderstanding, like I definitely expect you to be in a better spot. And all this stuff is just like you just do enough problems and you get better and whatever. So
Yeah.
like no
No,
one's like, I mean, people are better at it than others, but you still have to like study and practice and whatever. So
yeah, makes sense. No, thank you very much, and this was a helpful experience.
okay. Yeah, cool. Okay, did you have any other questions?
No, that's all. Thank you very much.
Okay, cool. See ya.